Dear students, in this session, let us see very important basics of two-dimensional geometry. What are the topics I'm going to cover in this session? Number one, let us see. It's actually a revision of the concepts of 2D geometry, which you have already studied in intermediate. It's just refreshing that concepts back. Okay, Cartesian coordinates. What are Cartesian coordinates? And what are polar coordinates, and what is the relation between them, relation between Cartesian coordinates and polar coordinates, and let us see what is the meaning behind graphs of functions, or just let us say we are looking at the geometry of the graphs of functions. So I hope you all will enjoy this session. Let's start now. First of all, I say what is meant by this. Let's talk about this Cartesian coordinates. As a formality, I would like to start up the thing with the very minimum basic, that is, I'll now take up this as x-axis and this as y-axis. We call this as x-axis and y-axis, you all know. So it may look very simple, but I suggest you to go through this complete video, because these all things are required to understand the problems of that multiple integrals. Now if I call this as 0 here, then it's going to be 1, 2, 3, so on, like this. 4, 5, 6, 7, 8, 9, 10. 10 will be here. So 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10 will be here. Now let us see how to locate certain points. This particular point is represented as 8 here, because it is 8 here, and corresponding to y it is 4. So 8 comma 4 is the representation of this one. Let me change the color for this one. Now if I want to represent this point, I'll take this as 4, and this is nothing but 7. So x value is 4 and y value is 7. Now using this concept, if I give the point here, then this point will be 2 comma 5, and this point will be 4 comma 5. If you go on taking the points on this particular line, I mean to say this line, then what is happening on this line? If I take this point for example, then this is 11, 12, 13, 13, but y value is 5. If you take this point, it is 8 comma 5. If you note all this, I would like to suggest you to see this one. This 5, this 5, this 5, and this 5. So if I look at all these points, then the only thing which is common in all the points is y is equal to 5. So y is equal to 5 is the equation of this particular straight line. And you all know that parallel lines will have only difference in the constant. So when y is equal to 5, this line will be some y is equal to, I'm sorry, I'll write like this. Now this is y is equal to some constant, but this is parallel. As it is parallel, it is constant. Okay, that constant changing. So what is the value of y here? That is 12. So y will be equal to 12 is the equation of this line, and y is equal to 5 is the equation of this line. So x-axis is going to get the equation as y equal to 0, because every point on that one is having y value equal to 0. There will be different x values, but y will be 0. This is one basic point. Next, second thing. Now if I take a point here, then One way to represent is drop this point here, whatever is there x, that x will be written here, and whatever y is there here, that y will appear. This is one way of representation. The other, this representation is called Cartesian coordinates. This x and y are called Cartesian coordinates. It is like the address of the point. This particular point A is having this address x comma y. That address can be given in another way. That another way address is in this way. I will change the color of the pen. You just okay, I'm writing that point same here. That same point I'm taking from origin, this particular distance, I'll just join this one. Now I measure this distance, this distance is r, suppose, and the angle made in radians is theta. Then that same point can be represented as r comma theta. So the point can be represented as x comma y in Cartesian coordinates. Same point can be represented as r comma theta in polar coordinates. So r comma theta are called polar coordinates of this same point A. Here this point A of A, Cartesian coordinates of A. Now as I discussed Cartesian and polar, now let us see what is the relation between these Cartesian coordinates and polar coordinates. For example, if r comma theta is given and x comma y is also the address of that same point, then the relation between x and y is, x is equal to r cos theta and y is equal to r sin theta. Now for example, if I take this much distance as just 1 unit and then this is 1 unit, so this particular point is going to become 1 comma 1. So the Cartesian coordinates are, I will cancel this, okay. So this is 1, and hence what happens here is this point is x comma y, that is 1 comma 1, and r comma theta now becomes like this. This distance will be, as per Pythagoras theorem, this is 1, okay, this distance is 1, this distance is 1, therefore this distance is root 2. Now root 2 comma pi by 4, that angle I have to write in radians, that is nothing but pi by 4. So this same point is getting two addresses. Now let us see, they are going to satisfy these particular equations. Now x is nothing but 1 is equal to root 2 into cos of pi by 4. Cos pi by 4 is 1 by root 2, you all know. So root 2 into 1 by root 2, that's equal to 1. So 1 equal to 1. And the value of y is, if you know the r value and the theta value, you can calculate the y value and the x value. So r is root 2 and sine of pi by 4, that is equal to root 2 into 1 by root 2, that's equal to 1. So 1 equal to 1 is getting satisfied. This is one way of looking at. Other way is nothing but, if we know r and theta, we can find what is x value and what is y value. If we know x and y, we can tell what is r and theta. So we can jump from this x and y to r and theta and the back, that is from r and theta to x and y. So this is the relation between x and y. That is the relation between Cartesian coordinates and polar coordinates. Now comes the very interesting thing, that is the graphs of functions. So let us see. Okay, this is x-axis. Now having that points cleared, let us talk now about how will be the equations of some curves. So I take a curve y is equal to f of x, and in a very simpler case I take that f of x as just x, so I take y is equal to x. Now y equal to x is the equation of a straight line passing through origin and making equal angles with x-axis and y-axis. Here it is 45 degrees. Now it is passing through the point 2 comma 2 3 comma 3, 4 comma 4, 5 comma 5, like that. So whatever point is there here, that x and y, they are equal. The relation between that x and y is equal to x. So it is passing through the point 2 comma 2, it is passing through the point 4 comma 4, it is passing through the point some alpha comma alpha. So if I take a line parallel to that one, then this is y is equal to x. Here y is equal to x plus some constant. There will be just a difference in the constant. Now if it is passing through the point 2 comma 0, this 0 comma 2. Now the thing is that it is passing through the point 0 comma 2. So if we substitute it here, we will be getting that y value, y is equal to x plus k, and it should pass through the point 0 comma 2. Then we substitute x value 0 and y value 2 in that one. So what we get is this y will be 2 is equal to x value 0 plus k, implies k is equal to 2. Therefore this line will be y is equal to x plus 2. You can see very clearly this is y is equal to x plus 1, x plus 2, x plus 3, like that. If it is having the intercept k, then it is y is equal to x plus k. So this is about the straight line. Now one fundamental point what you have to understand is that fundamental point that what you have to understand is that if there is any curve, then that curve will have point x and y. At different situations, at different positions, if you take, there will be some relation between x and y which is same here and same here, same relation, and that relation is equation of that curve. For example, if I take like this 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. So if you look at this one, then x is same as y. So that equation is nothing but y is equal to x. If you take it like this, y is equal to x plus 1. So wherever y is there, if you see here, x is 0, y is 1. So y is x plus 1, suppose. Then if x is 1, y will be 2. If x is 2, y will be 3. If x is 3, y will be 4. So that y is equal to x plus 1 is the equation of that straight line. And at last I would like to say just something. I'll just take 1 point 1 comma 1, not to using this graph in the background. If it is 2 here, 3, 4, I'll take this point 2 comma 4. This is 1 comma 1. I'll take the point 3 comma 9, roughly here 3 comma 9. I will join all these points, then I get a parabola on the left side also in this way. So the value of y, this y is nothing but the square of this x value. This 9 is the square of 3, this 4 is the square of 2, this 1 is this one. So y is nothing but the square of the x. So this is going to become the equation for that parabola. And last, concluding this one, if we have a straight line like this, I have taken for example 4, then it is a part of the circle and the radius is 4 units. So the relation between x and y will be x square plus y square is equal to 4 square. If I want to know what is y here for this x value, for example x is equal to 3.5, if I want to know what is y value, then from this equation y square is equal to 4 square minus x square, then y is equal to plus or minus under root of 4 square minus x square, that is 16 minus x square. So in short, y is equal to root of plus, I am taking plus because all the values of these points will have y positive because it is positive direction of y axis, and here it is negative direction of y axis. So if I take the lower curve, that will be y is equal to minus under root of 16 minus x square, and this will be y is equal to under root of 16 minus x square. Y is plus 16, here plus square root, and here it is minus square root. In general, for both the parts it is x square plus y square. This x square plus y square is equal to 4 square. So back to the point, if I want it for x value 3.5, what is the y value? Then I will be going 16 minus 3.5 whole square. So if I simplify this, I will get the y value. I hope you understood. This is very basic understandings. Now you will be having, for example, you have a curve like this, okay, straight line like this. Now 1 2 3 4 5, 1 2 3 4 5. I want the equation of this straight line. Then you have techniques of forming the equation of the straight line. You know very well that this is so simple. It is cutting x-axis at 5 and y-axis at 5. So x-intercept is 5 and y-intercept is 5. So x by 5 plus y by 5 is equal to 1 is the equation of the straight line. Taking that LCM and sending on the right hand side, we get x plus y is equal to 5. So the reality in all these points, the reality is, if you add up the x value and the y value, you will get the sum total equal to 5. You can check it here. Here the point is 5 comma 0 and 5 plus 0 is 5, satisfied here. If you take here 4, it will be 4 comma 1. So when x is 4, y value is 1. When x is 3, y value is 2. When x is 2, y value is 3. When x is 0, y value is 5. All these points. Not only that, 1.9 if x value is taken, then the value of y will be 3.1 and 1.9 plus 3.1 will be equal to 5. So for this 1.9, the value of y will be 3.1. I hope you understood. This is the way how we have to get the equations of the curves. If we have other two lines, 2 points, suppose x1 y1 and some x2 y2, then suppose this point is 4 comma 1 comma 4, suppose 1 comma 4, and here is the point, suppose I take 4 comma 6. Then the equation of the straight line passing through these 2 points x1 y1 and x2 y2 is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. So I can get it as y minus y1, that is 4, that's equal to y2. Y2 is 6. 6 minus 4 divided by x2 is 4 minus 1 into x minus 1, and y minus 4 is equal to 6 minus 4 is 2. 2 by 3 into x minus 1. Now multiplying with 3, 3y minus 12 is equal to 2x minus 2, and 2x minus 3y minus 12 becomes plus 12, so plus 10 is equal to 0. So this is the relation between x and y, and if I want to know what is the y value for any x value, what is the y value here? So this point is x comma y. I want to know what is the y value depending on this particular x value. Then that y will be equal to, from this same equation, that y will be equal to 2x plus 10 divided by 3, which I got it from here. I hope you understood. Thank you.